The definite integral. The definite integral of the function f of x from a to b is written as the integral from a to b of f of x dx. Now, you've not seen these things on the integral sign before. They're called limits. This is equal to the limit of the sum of the areas of the rectangles. So the integral from a to b of f of x dx is the limit as delta x tends to 0 of the sum of f of x delta x. So what we're looking at here are a series of infinitely thin rectangles. Delta x tends to 0 says that the width of the rectangles is going to 0. F of x is the height of the curve, delta x is the width. So we can see the area of that rectangle would be f of x delta x. That's also the limit as n tends to infinity of fxi delta xi. The n tends to infinity here is referring to the same situation as this. If the rectangles become infinitely thin, there'll be infinitely many of them. So n tends to infinity is the number of rectangles. And what it's saying is that there's some coordinate here, which is xi, and the height of the curve would be therefore f of xi, since this curve is y equals f of x. And the width, of course, is delta xi. And the delta xi, just as we were saying here, would tend towards 0. So if f of x is greater than 0, so we can see the curve is always above the x-axis, for x between a and b, as shown in the diagram below, this definite integral is equal to the area under the curve. We will look at evaluating definite integrals later, but for now we're going to look at evaluating them using more rectangles than in the previous section. And then we're going to move on to look at the properties of definite integrals before we get around to doing them using actual calculus techniques.